Welcome to the first titration challenge between Ms. Davidson and Mrs. Bain. We're going to show you what titration entails today, talk our way through it, but we also have a little competition going. And this is the part this is the part that the students always love, is competing with each other to see who can get the lightest pink solution that will last about 5 seconds. So that's our goal. All right, so I'm going to step out of the screen here and want you to explain this.
So our setup that we have is we'll have a ring stand, okay, and we have a burette, okay. So this burette, a couple things that students really struggle with is that it starts at 0 up here and goes to 50. You start your titration, you always fill it up to 0, and then you let it down and you figure out, okay, start 0, maybe I go to 10, so it'll be 10 milliliters. Okay, you want to make sure that you're exact. This is marked off in tenths. So what should that value be that we estimate? That last digit. So all our values should go to the hundredths place value. Okay, so you can see where how much exact solution you are using. Okay, so this is the other equipment that we need. We need an Erlenmeyer flask. Okay, and you'll need your acid and you will need your base. Okay, today we're using hydrochloric acid and sodium hydroxide. The last thing is an indicator. Okay, our indicator is going to be phenolphthalein. So
the principle behind titration is that we start with a solution with a known concentration. So in this case, it's going to be an acid. The acid is hydrochloric acid, so for each mole of hydrochloric acid, we get 1 mole of hydrogen ion. We're going to add phenolphthalein to the solution. Phenolphthalein is colorless in the presence of an acid, and it is bright pink in the presence of a base. So what we'll do is we will add the base to the acid in small increments until we get to that tipping point, the point at which the number of hydroxide ions and hydrogen ions are exactly the same. Once we go over that tipping point, the solution will turn pink. So our goal is to get it to be just slightly pink and not go over and get it that bright pink.
in our burette, we are going to put our base. And the first, you want to make sure, so on the bottom, the thing that you turn, this is called a stopcock. And so you want to make sure that it is parallel with the counter to make sure that it is closed. Otherwise, all your liquid will go out of it. And then that's you want to fill up your burette. And if you go a little bit past 0, oops, I did a lot past 0, you are going to want to make sure you start at that 0 point. So in your waste container, just let it go a little bit. I'm practicing. Oh, I went too far. All right. So this is how we set it up. Okay. Once you have your base in your burette, you are going to then want to measure out your acid. So we're going to be using 10 milliliters, okay, of our hydrochloric acid. I'm a little rusty here, guys. So So I am doing just drop by drop, and I am constantly swirling it.
As soon as it's swirled, the hydroxide and hydrogen and hey, that's not too bad. Not bad to think. And the color goes away. As a matter of fact,
I did not go too far.
that's not.
And I was in college. We learned how to do half drops. I don't even speak anymore. One half. One with you. I went too far. I need a half drop. So this currently I will say, I think is the wine, of course.
It's not like a color. Oh. Okay.
Already put my acid in here. Just read the burette to see where we were at. Okay, so we're gonna try this one more time. Whew. This is like end all be all. Let's see if I can get smaller drops. Oh no. Yeah. Well, it's really pink, but it's not anymore. All right.
That actually looks really good. Fourth time's a charm.
You beat me. All right, so since Miss Bain won, I get the job of explaining what was going on. Okay. So we start with our titration calculation. So MA VA equals MB VP. Find all of our information. Okay. And so this is our data table. I found the average for all of them, okay? And so we want to solve for that molarity of the acid, okay? So molarity of the acid will equal molarity of the base times the volume of the base all over the volume of the acid. So we'll plug in our numbers. All right, so our molarity of the base is 0.3 molar, and the molarity, or the volume of the base was, our average, was 10.3 milliliters. All right, and our volume of our acid, that was 20 milliliters. Okay, and so when we get the math, we are finished with it. Our molarity of our acid was 0.15 molar. Okay, and so that's just saying we were able to calculate what was that unknown acid.
Okay. All right, so now that we have our data, because we made the solutions beforehand, we kind of had an idea of what the molarity was supposed to be. And it's close, but one of the things I thought we could talk about really quickly is why the amount of base that we needed to titrate the acid increased. And we still came up with the amount that we, or the molarity that we thought we would.
So one thing when we made acids, we started with a 1 molar concentration. So this gets back into solutions and talking about dilutions. And so when we made these, one thing that we think happened was I measured out the amount of acid that I need, and then I just put the distilled water. This is not the proper way to make a solution. Y'all know that. But we did not, one of the reasons why we think we didn't get it mixed up well enough.
Right. The acid is more dense than the water, so it probably stayed in the bottom of the graduated cylinder, so it took less, or it took more base to titrate it and to get to that average as we went along.
Or using the burettes was challenging. We don't use these very often. We use them once a year. Obviously, this year we're not using them at all. So when you're actually using the stopcock, it is really hard to actually turn them. And so you are set with the amount of drops. And as you can tell with most of our drops or most of our solutions, that last drop was just too much. So that was a big thing with titrations. If you do this in college, you will have equipment that would be a lot, they use it more often, or they might have stuff that's a little bit more scientific.
An example of another piece of equipment that we could have used would have been a magnetic stirrer, which looks kind of like a hot plate, but then you put a little magnet, plastic covered magnet in the bottom of your beaker, and when you turn the magnetic stirrer on, it causes it to spin. So the stirring takes place automatically for you, so you're not trying to manage the drops and the stirring at the same time.
Or if you're able to have more lab partners, somebody's always stirring while somebody else is always doing the drops.
Especially if you don't have to use the approach.
Yes. So. Well, Miss Bain won, and I'm probably the most competitive person ever. So it hurts. But
how about this? Winner buys coffee.
Winner buys coffee? Yes.
All right.
Cool. Awesome. Well, have a great rest of your week.
Yep. Again, we're really sad that you couldn't be here to do this one. It's one students really like the best. So I hope you all go on to take chemistry in college so that you can do fun labs like this. Spring is really when we do some of the more interesting and fun labs, and we've missed that. So.
Mm-hmm. So, and I was just talking to a former student who was just talking about this, and she was bummed that you guys got to miss it. Yeah. So we wish we could be here, but we wish you guys could be in our classrooms. Right. We miss this part. Right. We miss all of you.
Stay safe. Get your stuff done.
Yes, get your stuff done so that we can stop pounding you.
All right.
So,
Bye-bye.
all right,